All right, so we're going to start the next unit in our Algebra 1 life here, and we're going to start talking about polynomials. We're going to learn what polynomials are in just a moment, and we're going to learn how to perform all kinds of different operations with them: adding, subtracting, multiplying, dividing, factoring, which is kind of a form of dividing, and all that kind of stuff. Really big unit in Algebra 1, one of those things that you really need to make sure that you grasp pretty well, because you'll be seeing a lot of this going forward. Okay, so first off, the point of the video here, the point of today is to classify polynomials so that you know the verbiage, the terminology. Then we're going to talk about how to add and subtract, which is pretty easy. Okay, first and foremost, monomial. What is a monomial? A monomial, mono meaning one, is a real number, a variable, or product of a real number and one or more variables with whole number exponents. Okay, I'll show you some examples in a minute. Every monomial has a degree. The degree of the monomial is simply the sum of the exponents on the variables, right? We don't count exponents on numbers, we count the exponents on variables and add them up. So some monomials are here, okay? This guy is a monomial. It is the product of a real number and one variable, right? This guy is a monomial. It is the product of a real number and one or more variables with whole number exponents, okay? This guy is a monomial. It's simply a real number. This guy is a monomial, just like 5x is, because it's a real number and a couple of variables, and that's okay. This guy is a monomial. Okay? Now, degrees. Look at 5x. The degree is the sum of the exponents on the variables. Well, the exponents on this variable is simply a 1, so this degree is degree 1. This one is 5 plus 2, so this one is degree 7. This guy doesn't have a variable, so you can imagine this could be x to the 0, because x to the 0 is 1, and 9 times 1 is 9. So we can pretend like it has a variable with an exponent of 0, but at any rate, if there are no variables, then the degree is just going to be 0. Here, the degree is, any guesses? 2, right? Exponent of 1, exponent of 1, 1 plus 1 is 2. And here is a degree of 0. Okay? Now, a polynomial. Poly meaning many. A polynomial is an expression which is the sum of monomials. Okay? When we write polynomials, we write them in standard form. This is sort of a, if you want to think of it as math OCD, right? We want to make it look a particular way. And for polynomials, what we do is we start with the degree, the highest degree monomial. And then we go work left to right and decrease the degrees as we go, right? So for example, this guy is a polynomial. It is the sum. Here's a monomial, here's a monomial, here's a monomial, and here's a monomial. And it's the sum of all these monomials. And yes, even this minus 5x is the sum of a monomial if you consider changing this minus to a plus, which means you also have to change the sign of whatever monomial is behind it. Okay? So it's the sum of monomials. Those are all monomials. And this is in standard form, because the degree of this monomial is degree 5, this one is degree 3, this one is degree 1, and this one is degree 0. So it goes in decreasing order. Okay? So standard form. Now, polynomials have degrees, and it's different sometimes than the degree of the monomials. Like I said, this monomial is degree 5, this one's 3, this one's 1, this one's 0. So what's the degree of the polynomial? It's the same as the highest degree monomial. So the degree of this polynomial, this whole polynomial, the degree is 5. That's the highest degree monomial. Okay? All right. So let's try our hand at some of this terminology. If we had a polynomial that looked like this, 8, then the standard form would just be 8. Okay, there are no other monomials to line up. The degree is 0 because the degree on this monomial is 0. There are no variables, right? If the degree of the polynomial is 0, then we call that polynomial a constant. And you've heard that before. Real numbers without variables are simply called constants because we constantly know what the value is. Okay? Now, in this polynomial, there's one term, and because there's one term, we name the polynomial based on the number of terms as well. And since there's one, mono meaning one, this is a monomial. Okay? Now, next guy, this next polynomial, 4 plus 2x. The standard form, okay? Well, look at the monomials. This one's degree 1, this one's degree 0. So the degree 1 monomial needs to come first, and then the degree 0. And notice that when I switched these terms, the signs came with them, okay? This plus sign is going to be attached to this 2x and go wherever the 2x goes. Now, if 2x is written first, it's a positive 2x, and we don't need the plus sign. Just like we know this is positive 4, so we could write in a plus 4 if we wanted to, and when we move that 4 behind the 2x, we make it a plus 4. Okay? The degree of this polynomial is equal to the highest degree monomial, which again is 1. If the degree of a polynomial is 1, then we name it using the degree, and we call it a linear polynomial. And we've been doing a lot of linear functions, linear inequalities. We've been graphing and solving systems of linear equations and inequalities, and if you remember, all the exponents on those variables were 1, right? So all the monomials had a degree of 1, so the polynomial had a degree of 1. Now this guy has 2 terms, has 2 monomials in there. And if it has 2 monomials, the prefix meaning 2 is bi, so we call this a binomial. Okay, next guy. Okay, highest degree, we're going 1, 2, 0. So the positive 3x squared goes first. The positive 7x goes next, and the negative 5 follows. Right, so the degree of this polynomial is 2, which makes it a quadratic. And quad is a little misleading, but it's what it's called. It's called a quadratic. Now there are 3 terms, and when a polynomial has 3 terms, we call it a trinomial. And we'll be doing lots of things with binomials and trinomials and those kinds of things. So we have to understand those terminologies. Next guy, 4x to the third, written in standard form. What do you think? Yeah, it's going to be 4x to the third. The degree of this polynomial is 3, because that's the highest monomial degree, which makes it a cubic. We call it a cubic polynomial. It has 1 term, so we're back to this guy being a monomial. Okay, and then the last guy. I'm going to give you a couple of seconds. Stop the video, try to write it in standard form, come up with the degree of the polynomial, the number of terms, and then name the polynomial based on the number of terms. Go ahead, and then start it up again and check your answers. Okay, what'd you get? You should have gotten 6a to the 4th plus 4a to the 3rd minus 3a plus 7 for your standard form. So we went degree 4, degree 3, degree 1, degree 0. Now the degree of the polynomial is 4, which is why it's called a 4th degree polynomial. There are 4 terms, and so we call this thing just simply a polynomial. There is no quadrinomial or anything like that. Okay? So there you go. Just some terminology that you need to be familiar with because you're going to come across it again. All right, so adding, if we wanted to add 2 polynomials. So here's a cubic trinomial, and we're going to add it to another cubic trinomial. Okay, if that's the case, then we simply add the like terms. Remember, once upon a time, way back when, we talked about like terms. Like terms are the terms that have the same variables with the same exponents. Okay, now we're going to want to write our answer in standard form, so we might as well go ahead and put it in standard form as we add them. In other words, grab the highest degreed monomials and add those two together first. Now, what are our highest degreed monomials? Well, this one's a degree 3, this one's a 1, this is a 0. This is a 3, this is a 1, this is a 0. So I want to add my degree 3's together. 5, and when we do that, we just add the coefficients. 5 plus negative 7 is negative 2x to the third. Don't need those anymore. And then my degree 1's, 6x and 8x, add those and you get 14x. Don't need those. And then negative 3 and negative 7 are negative 10. And that's your new polynomial. That's your new cubic trinomial. Okay? Think you got it? Again, give it a shot here and start the video back up and see how you do. Okay, did you come up with this? 4w to the 6th plus 7w to the 5th minus w to the 3rd plus 2w squared minus 2w plus 7. Now, where did that come from? Now, if you see, I keep listing the degree of each monomial up above. Okay, maybe that's something that you want to do to help you locate those like terms. Okay, so the highest degree monomial is this degree 6. So I don't see any other degree 6's up here, so I'm not going to be able to combine it with anything. So I just bring it down, 4w to the 6th. Then my next degree down would be a degree 5 if I had any, and I've got 2 right here and right here. So I add the 8 and the negative 1 and I get 7. So 7w to the 5th. My next highest degree monomial would be a degree 4, but there are no degree 4 monomials, so I move on to my degree 3's, and there's a negative 9w to the 3rd and 8w to the 3rd that I'm going to add together and get negative 1. So there's your negative 1. Then your degree 2's, which are here and here, add those, you get 2w squared. And then your degree 1's, which are here, negative 2w. And your degree 0's, which are here and here, 1 plus 6 is 7. Now, I want you to pay attention to the fact that when I add two monomials with the same degree, the exponent did not change. Okay? The only way we change exponents is if we multiply, divide, or raise a power to a power. So I only want to add the coefficients, not the exponents. Okay? All right. Moving on. Now, we could add horizontally, which is what I just showed you. Or it is possible for us to add vertically. Now, this vertical method can be a bit misleading. It's not my favorite method, but it's there. It's out there. It exists. And so, very possible that you're going to see it. So we need to talk about it. The idea behind the vertical method is really you want to create some columns of your similar degreed monomials. Okay? Now, really what we're doing is we're combining like terms. I've got this cubic trinomial plus this cubic trinomial, and we just want to combine like terms. Okay? So if you can see the like terms without doing what I'm getting ready to show you, then so be it. But it's helpful to line these up in degree columns, if you will. And so in other words, I can rewrite this as 15q to the third and 7q to the third underneath of it, because those are the same degree monomials. The next degree down will be a degree 2, and the bottom guy has a degree 2, but the top guy doesn't. So you could leave a space here and make this your degree 2 column without having a degree 2 in the top. Then your next is degree 1, and this guy, the top guy, has a degree 1, negative 6q. The bottom guy doesn't, so I can leave a space for the degree 1 in the bottom guy, and then bring over the two degree 0's. And now just add your columns. Right? And so this would become 22q to the third plus 2q squared minus 6q plus 25. Okay? Now, like I said, if you can see the like terms without worrying about filling in spaces, then don't worry about it. This is just something that you can maybe do a couple of times to make sure that you understand and that you're careful enough to look at the degrees and make sure you're combining like terms. Okay? All right. Hopefully that's easy enough. So give it a shot here. If you want to rewrite, you can. If you think you need to, you can. If not, just combine the like terms and we'll move on. Okay, what'd you come up with? Well, 8 plus negative 8 is 0, so you get 0 u to the 4th. Negative 6 plus 6 is 0 u squared. And 8 plus 8 is 16. Now, 0 times u to the 4th is 0. 0 times u squared is 0. And then you have your plus 16. Well, 0 plus 16 is just 16. So you should end up with just 16. But I wanted to make sure that we added the zeros in here because the 8u to the 4th and the negative 8u to the 4th don't just simply cancel, right? That's what a lot of people say. And we don't want to say that because you got to start thinking that they just eliminate and there's nothing there. And the problem is there's a 0 there. Now it turns out we don't need to write the 0 because we're getting 0 plus 16, and so we just get 16. But sometimes those zeros are very necessary placeholders, and so we have to add them in. So we need to understand that they're there, we just don't have to have them there sometimes. Okay? So there you go. Now, subtraction. Okay? Polynomial subtraction is not a whole lot different than addition. And as a matter of fact, it's a lot like if we had 5 minus a negative 3. You were taught early on to make this minus sign a plus, and when you did that, to change the sign of the number behind it. Okay? Change the sign of whatever's behind it. And in that instance right here, it was just a simple real number. Now we're going to have an entire polynomial behind that minus sign. So when I change this to a plus, I have to change the sign to everything inside this polynomial that comes behind it, and just behind it, right? Going back to my 5 minus negative 3, we didn't make this a plus and this a plus and then change the sign of the 5. We don't do that. We don't change what's in front. We only change what's behind. And so this becomes negative 4 minus a to the 3rd plus 5a squared minus 10, and now we're going to go through and combine like terms, just adding the coefficients. So degree 5 is the highest I see. There's those guys. 8 and negative 4 give you 8a to the 5th. Then we've got, see, I don't need those anymore. So I've got negative 2a to the 3rd and negative a to the 3rd, so I get negative 3a to the 3rd. Don't need those anymore. I have a squared and 5a squared, so I get plus 6a squared. I don't need those anymore. And then 8 and negative 10 is negative 2. Okay? And so, there's our new polynomial after we subtract. Okay? All right. So you try. Give this guy a shot. Stop the video. See what you come up with. Okay? So we're going to make this a plus, this a minus, this a plus, this a plus, and this a minus. Changing just the polynomial behind the minus sign. So then we get 2 plus negative 7 is negative 5y to the 3rd. Then we get negative 8 and positive 6, which is negative 2y squared. Then we get plus 7y, and then we get negative 13. And we're done. Okay? Now, we can do this vertically as well. You can go through and rewrite to fill, to add spaces if you're missing any degrees from either of your polynomials, or you can simply combine like terms after you've changed this minus to a plus and change the sign to everything inside of here. But only, again, only the bottom one, not the top one. We only change the sign of the polynomial that comes after the minus sign. And then we combine like terms. We get negative 4j to the 7th. This is negative 10j to the 3rd. That's a pretty rough looking j. Then we get, oh, look at that, 4 plus negative 4 is 0. 0 times j squared is 0. And then we get plus 11. But then we can combine these guys because they're like terms now. And 0 plus 11, of course, is just 11. Okay, that's it. You try vertical subtraction. Remember to change the signs and then combine like terms. Did you get this? 22q to the third minus 2q squared minus 6q minus 5. Now you had to be careful right here because these guys were not like terms. So if they don't have like terms, we just bring them down. Okay? And making sure that we carry the sign with it, minus or positive or negative. Okay? Now we're going to mix them up. So so for every one of these, I'll give you a minute, stop the video, work it out, and then start it back up and see if you're right. Did you get, for number 9, negative f to the third plus 2f squared minus 7f minus 4? Okay, that's what you should have come up with. Look again, these guys are not like terms, so be careful. Okay, now try this guy. And did you get 12a to the fifth minus a to the third minus 4a squared plus 18? I hope that you did. Okay, try this guy. Remember, change signs because we're subtracting. You gotta know, you gotta pay attention when you're subtracting or adding. Okay, so stop the video, start it back up when you're done. Should have gotten 12x to the third minus 2x plus 4. Okay, and last but not least, try this guy. And you should have 16j to the seventh plus 8j squared plus 5. Okay? Now, if you're still confused, make sure you come see me during STAR or after school. Otherwise, homework's out in Canvas. See you next time.